So let's look at another example of a neutralization reaction. In this case, we're going to look at the reaction of sulfuric acid and potassium hydroxide. And so the first thing that we want to do is figure out what are the formulas for each of these things. Now, sulfuric acid, this is one where it goes back and it helps to think, if something ends in ic for acid, it must be that the parent came from 8. And so this must be sulfate there. And so how do we get that? Well, it must be that H plus and sulfate paired up, SO4 with a -2. And so we'd expect to get H2SO4 is one of our products, or reactants. Potassium hydroxide, K is a plus, OH is a minus. We'd get KOH as our other product. Now, like I said before, we've already done a lot of the work when we're given the names. Now we just got to pair up H and OH, and we would get HOH, H plus and OH minus would give us HOH, which is also water. And then the SO4 with the -2, K plus would pair up with that. K plus SO4 with a -2, you'd get K2SO4. Okay, so now in neutralization, we don't have to decide whether a reaction will occur, we just have to include states of matter now. H2SO4, in order to help us identify that something's an acid, it helps to write AQ after it. Anything with potassium is AQ. Anything that has water L is just an L, and then anything with potassium, again, is AQ. And then one other thing, we should balance this. I didn't mean to forget that. There are 2 potassiums on this side, so I could put a 2 in front of that. Think about this again. There's 2 OHs on this side. There are 2 H pluses. Those will combine together to give you 2 waters. So we'd put a 2 in front of that there. And then we would say that this is the balanced neutralization reaction.